Hi everyone, and welcome to the Table, Charts, and Graphs Oh My lecture video. Bet you can't guess what we're going to discuss in this video, huh? So we've already talked about frequency tables previously. Tables are used a lot for more simple variables, but a lot of times your variable is more complex with a lot of categories or a lot more frequency values, and it makes the table less easy to interpret. In these cases, we turn to charts and graphs. These can help us visualize the information much more quickly. Now, I'm not going to spend a lot of time on the specific types of charts and graphs because I think a lot of you are mostly familiar with them. But I am going to add in some research methods know-how to your graph building expertise. First off, we'll go over quick examples of the typical charts and graphs, starting with pie charts, then bar graphs, histograms, line charts, and maps. For the most part, you can select the type of graph based on your own personal preference. However, there are some no-nos when it comes to graphing, depending on the level of measurement of your variable and the number of categories in the variable. If you have a nominal level variable, you will want to use either pie charts, bar graphs, or histograms. I'm sure you're familiar with the first two, but you may not have heard of the last type of graph. A histogram is a special type of bar graph that's used for continuous categories. The bars in a bar graph are separated, but the bars in a histogram touch one another. So it's useful for variables that continue across all the values. And I'll show you what I mean in a second. Bar graphs and histograms have no category limits. They can be as big as they need to be. But you do need to watch out with pie charts. Ideally, a pie chart should only be used when there are 6 categories or less. Here's an example of some pie charts. Notice that one of the pie charts depicts the standardized percentage values for each category, and the other depicts straight frequencies. It doesn't matter. It's researcher preference here. But typically we'll see percentages used because then you can make comparisons more easily later on. Now I want you to take a look at these charts for a second and think about which one is easier to read. And why did you say that? Now you probably indicated that the percentage chart is easier to read. And this is for 2 reasons. First, the grayscale color palette makes it easier to look at because all of the colors aren't trying to outdo one another for your attention. Second, notice the number of categories. The percentage chart only includes 4 categories, so it's easy to see the breakdown. The frequency chart includes 9 separate categories, and that makes it really difficult to compare the frequencies quickly. The size differences become smaller every time you add another category, so it's more difficult to do the comparisons that this chart is designed to show you. Here are some standard bar graphs. Like pie charts, bar graphs can be used for standard frequencies or standardized values like percentages and proportions. They can also go negative, like the example shown here on the right. And finally, here is a histogram. Notice it's the same as a bar graph, except the bars are right next to each other. This is appropriate for an ordinal level variable whose values increase chronologically, like in this example where height goes from 58 to 60 to 62 to 64 and so on. Now, if you have interval or ratio level data, you can use any of the 3 methods we just talked about, or you can use another method called the line graph. This is probably one of the most common methods of data visualization for numerical values. Here's a simple line graph that uses x as the time as the x-axis and percentages as the y-axis. And that's a pretty common way to set it up. Now, just like univariate tables, sometimes we find that bivariate analyses are better depicted with charts and graphs. Multivariate bar graphs are one way that we can show distributions of multiple variables in the same graph. The bar graph on the left is called a stacked bar graph. It's essentially like 3 pie charts stuck together vertically, one for each category. While this can be helpful with major differences or to illustrate a pattern, this type of bar graph is not very good for displaying actual values. For instance, trying to figure out the specific value of that orange bar is really hard because it starts somewhere in the middle of the chart and it ends somewhere else in the middle. But you can easily see that the percentage of red values, which indicates freshmen in this chart, is decreasing each year, and the percentage of yellow values, which indicates juniors, is increasing. So the overall trend is really easy to see. Now, clustered bar graphs are more common. These graphs look like 3 separate bar graphs merged together, with colors or patterns used to distinguish between the different variables. In this example here, the graph is designed to show us the distribution of freshmen, sophomores, and juniors by year. So time is the independent variable, as we are wondering what type of effect time is having on student class. the dependent variable. Like clustered bar graphs, line graphs can be used to depict the distributions of multiple variables at the same time, using color or line pattern to distinguish between the two variables. One caution here is to avoid clustering too many variables onto the same graph. Notice how only 4 lines are really visible on the graph on the right. Everything else is just a cluster of lines at the bottom. In this case, breaking the graph into multiple graphs can be the most helpful so as to better illustrate the breakdown. Now, it's not always the best thing to provide the readers with complicated multivariate graphs. Sometimes a simple univariate graph repeated for each category of the independent variable can illustrate the point best. Again, notice my theme here: simplify, simplify, simplify. All you care about is how well the graphs convey the information, not how fancy they look. Now, I expect that most of these different graphs are things that you're familiar with and maybe even comfortable creating and analyze. I do have a few tips about univariate charts and graphs. First, labels are important. A graph should always include a title, a key, or a legend that identifies the response options that are depicted, and an axis label so that the readers know what values are being depicted in the graph. Again, the specific labeling method is up to you, but you should consider using standardized values if you want your readers to be able to compare everything later. Another tip: missing data. Something that you may not be familiar with in charts and graphs is missing data. It's important to acknowledge missing data in scientific studies. The easiest way to do that is to provide the total number of values used to create the graph using the n equals notation. This can be done in the title or the footnote of the graph. And finally, simplify, simplify, simplify. Nowadays, it's easy to make complicated charts. Excel will do it automatically for you. It'll add in multiple layers, it'll take on flashy colors, 3D perspective, you name it. But here's the problem. The more complicated the graph, the more difficult it is to read. And the whole point of graphics is to be a quick and easy communication to the reader. For instance, look at these two pie charts. Let's get both on the screen. There we go. Look at these two pie charts. One of them looks super fancy with the pie slices chunked up and dimensionalized. But how easy is it to compare sections of this graph? Not as easy as the second graph. The second graph may be more boring to look at, but it conveys the information easily and quickly. And that's the goal of the graph. So remember, fancy is not always better. Now, the last thing I want to leave you with is a discussion about which option is better for you, graphs or tables. Well, it all depends on the purpose of the visualization. Tables are better if you want your readers to know specific values, but they can get complicated and very difficult to read very quickly. Graphics don't tend to show specific number values as easily, but they're best for making comparisons and showing relationships quickly. So it's all up to you and what you need from the visualization. All right, well, that concludes our discussion of tables, charts, and graphs. Thanks for watching, everyone.